Hi students, this is a really quick lesson on IXL, the 7th grade section A.1, prime or composite numbers. Before we start, I want to show you what I always do with my students when we're studying prime and composite numbers. We use a 100 chart. So a chart with numbers 1 through 100, and we create our own little tool that we're going to use for prime and composite numbers. And so the first thing we do is we talk about, well, what is a prime and composite number? What is a prime number? What is a composite number? A prime number has exactly two factors, one and itself. And then composite numbers are all the other numbers on the chart. They have more than two factors. So if we talk about numbers that have exactly two factors, one and itself, one isn't included in that because one only has one factor, itself. So we start by just marking out the 1, okay? And then we circle the first prime number, which is going to be 2. And so that's our first prime number because 2 has two factors, 1 and itself, 1 and 2. All right, so then what we do is we find all the multiples of 2 because, of course, if they have factors of 1 and 2 and themselves, then they can't be prime numbers. So, for example, 4. 4 can't be a prime number because its factors are 1, 2, and 4. So it can't be a prime number. So then we go across here and we do all the even numbers. So, of course, all the even numbers are going to be composite except for 2. So really, they're all in rows, aren't they? So all I really have to do is just mark these out. I'm sorry, I said rows and I should have said columns. They're all in columns. So all of these are even. All of these are even. Let me get a better pen to do this with. All these are even. Mark all them out. All these are even. And then everything under the 4 and everything under the 2. So that just eliminates a lot of numbers that are not prime. They're all composite. All right, so let's go to our next prime number. Our next prime number, of course, is the 3. And then any multiple of 3 is also going to be composite because it has at least 1, 3 in itself. So let's look at multiples of 3. Well, we've already marked out 6. Here's a 9. 12, 15. So the next one's 21. After that, it's going to be 27. Let's see, the next one's 33, 39, and so on. So we can go through and mark out, and what you'll find is it's going to make a pattern. And so what I'm seeing is, like on this this column right here, it's 3, and then count 1, 2, 3, and it's that number, 1, 2, 3, and yep, 63, 1, 2, 3, 93. Another trick for knowing whether a number is divisible by 3 is if you add up the digits, like let's take the 45. Well, 4 plus 5 is 9. If that number is divisible by 3, then that big number is divisible by 3. Let's see, 75. 7 plus 5 is 12. Yep, 12 is divisible by 3. Also, you see 1, 2, 3, 1, 2, 3. Let's try this one. 1, 2, 3, 1, 2, 3. Yep, 57 is divisible. 1, 2, 3. 87. 8 plus 7 is 15. Yep, it is. All right, same thing here. 3. And let's try this one. 1, 2, 3, 1, 2, 51, and 81. It looks like we got all the multiples of 3. All right, so all the multiples of 5. 5 is a prime number. Multiples of 5 is pretty easy. It's all the ones in this column. And we already marked out all the ones that end in 0, so we got all those already. 7 is another prime number. Has two factors, 1 and 7. Do we have any multiples of 7 left? Yep, there's a 49. And let's see, after 49, 77 is one. 7 times 11. And I think that might be, I should have marked up the 98. I think that's the last one. I can check and make sure. So after this, we've got 11 is prime. Now, all the 11, the multiples of 11 are, I think they're a diagonal going this way, and we've already marked them all out. So 13 is another one, and so on. I'm not going to finish all this, but what you do is you look at the prime number. 17 is 1, 19 is 1, 23 is prime, and then look for any I'm sorry, not factors, multiples of those numbers. 31 is prime. I'm trying to think. 51 is a number that a lot of students think is a prime number, but it is not a prime number because it's divisible by 3 and 17. Okay, so there should be, let me just call them out. Let's see, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37 is prime. Oh, I changed colors, I didn't even know. 41, 43, 47 is prime, 53, 59, 61, and 71. Let's go ahead and do those together. 67 is prime, 73, 79, 89, 83, 91 is not prime, so let's mark that one out. And then 97. I believe there are 25 on this chart that are prime numbers. Now let's go back to our IXL. Is 13 prime or composite? It's on our chart. So if you have your chart, you can see. Now, there is no even number that is a prime number besides the number 2. So if you see an even number, it's composite if it's not 2. 3 is a prime number. It's on our chart. Is 8 prime or composite? It's even and it's greater than 2, so it is composite. 43, well, I could go back to my chart and see that that's one of my prime numbers that I circled. 27, nope, that one's divisible by 3 and 9, so that's composite. So anyway, use your chart, and if you can make one yourself, you can probably find one online as well. So that's section A.1 in the 7th grade IXL.